Hey, what's up, everybody? Welcome back to another Lair Belair, the live edition. Good morning, everybody out there. It is still the morning, I believe, 11 a.m. here in the Eastern Time in South Florida. And just wanted to share with you guys a quick, I think it'll be kind of quick, like a half hour, maybe an hour, live stream today on the continuation of PiGRRL project. I've been making some progress behind the scenes. Last part I showed you guys how to make a tester, this guy here, for the Adafruit PiTFT, the 2.2-inch version, which is going to be used in this project. And I have went ahead and designed the rest of the components and made a sort of prototype of the case. So this is the case. It's a little two-piece enclosure. And no screws in the back. It's going to be all snap fit together. So what I wanted to do in this session is just go through some of the tweaks and minor edits that I have to make. Things do fit, but not everything fits perfectly. So the way this is going to work is pretty similar to the other builds. Again, the Raspberry Pi is just going to, the Pi Zero is going to go into the header like this. And it's going to go into the case like that. Screws are going to get mounted in here. And the thing that doesn't fit right now is I actually have a lip on this second piece, the second part of the case, and I didn't accommodate for the lip, so I can't close the case. So we'll make a quick edit in Autodesk Fusion 360, and then I also wanted to move the D-pad and the action buttons closer to the screen inwards this way, because they're a little bit onto the edge here, and just for ergonomics sake, I think it'll be better that way. Let's go through some other things. The power boost doesn't have any screws mounted to this piece here. There's a little opening for the USB, the micro USB port, so you can charge it. But yeah, there's just standoffs with little pegs, and it's just held in place very nicely. So that's pretty cool. No screws for that one. The only screws you'll need is for these PCBs. These are prototype PCBs. So you could use these. This is, of course, the Primer Proto, half size. But I'm going to design in EagleCAD these D-pad / action button PCBs. And it's going to be really simple. It's going to have like 4 or 6 headers up here. And you won't have to worry about any ground because they'll all be wired to ground through traces. And you'll just have to put these tack switches in there. And they'll have 2 mounting holes right here and right here, and that way it's mounted to these guys here, so it'll be like this. Now the interesting thing about this is I'm going to make it so, since you have to wire through the header anyway, I'm going to just make just use 2 of the same thing, right? 2 of the same PCBs, because they're pretty much the exact same size here and here. Just one has this D-pad, and then this one has these little circular buttons. Interesting thing is that this is the sort of traditional D-pad from these Super Nintendo controllers. It sort of fits. It sort of fits in there. The only thing that doesn't fit is there's such a large fillet here on the edge of the button that this one's a little bit sharper. So if you wanted to reuse this, I suppose you could with a little bit of edit, but I don't plan to. I plan to 3D print this part in NinjaFlex, because you get better rubberiness, since it's the elastomer, the rubber. So yeah, and then of course these 4 buttons down here are for the PiTFT, and I actually already went ahead and did a small edit. You can see here this button didn't line up so well, so I opened the part up in EagleCAD and found, oh, I messed up one of my measurements. So good benefit of being able to open stuff in EagleCAD and referencing all your stuff. So let's go ahead and jump into CAD. Whoa, one last thing. I was going to use a 500 milliamp battery. I went ahead and said, why not a 2000 milliamp battery? It is kind of chunky. Now, the overall size of this thing is going to be about 20 millimeters. So it's kind of thick. I really wanted it to be thinner, but once you stack things on top of each other, things get thick. So you can see here, this is nice and thin. That's great. Once you add a battery, it gets a little thick. You can see here compared to it, and you want to have a little bit of extra space, you know, for wires, of course. But if you wanted to remix the design and use a smaller battery, you could totally do that. And you could do this. See how I have it? It's a teeny bit thinner, but then you have all this excess here. So it's like, what do I want to do? So I'm just making it a little bit chunky, and it's better to have a bigger battery, I think, than a smaller battery. So I think that's about all the components for the project. So making progress. So let's go ahead and look at the CAD real quick. Let me jump to that. Here's the CAD. Okay, so here's the case in Fusion 360. And what I'll do is I'll turn on the section analysis so I can get a cross section, so you can see inside of the case. Right there. And I already have one turned on. So you'll see here in this side that this is the Raspberry Pi PCB, and it is intersecting with that lip from the bottom part. So I need to push it out a little bit. But that's pretty straightforward and easy to do because everything's derived from one sketch. So let's take a look at my sketches here. So this is the case sketch. I actually do not have any dimensions set to it. It's pretty freeform because I wasn't exactly sure what the dimensions needed to be. So that's what's cool. Sometimes you just need to make a sketch and don't apply any dimensions and just work from it and just kind of keep tweaking it until you get something that fits. So I'm gonna move this guy up a little bit, and to do that I'm just gonna double click on the sketch and then just move it up a bit. How much? It's probably 1.5 millimeters, something like that. Let's hit stop sketch. When I hit stop sketch, it'll carry everything over and do all the stuff here that's been done, all the features, all the extrudes and cuts and whatnot. So let's hide the sketches for a second and turn the analysis back on, and then we can see I have just about enough clearance, a little bit extra, why not, just for those extra wires and things that might pass through there. So that's looking pretty good. No intersections there. And I did have a small intersection problem here because I forgot to mention that I 3D printed these washers for screws so that this doesn't happen. Let me switch back to the overhead here. I've seen folks have this issue. I myself have this issue. Do you see that little bump there? That little bump is a screw. The screw went too far. Oh no. And that sucks. When you screw into here, sometimes you don't know how far you go and you kind of break through the surface of the case. So to prevent that, I 3D printed these washers here. So this will prevent you from going all the way in there. So you can see once the PCB is in there, there's no way to go all the way deep in there. So this just prevents that from happening. So I made these little washers. So that's about it. That's the story behind there. And the thing is that since the washers are relatively big, I need some more clearance for these washers. So I need to move the bottom area as well. So I need to push that back down a bit. So I'll do that again by double clicking on the case and turn on the sketches, and then I'll just push it down like by 2 bars here. That should be enough, I think. I'll hit stop sketch, turn off the section analysis once it's set, and turn off the sketches again. Let's turn that off, turn that on. Let's see how much clearance we have. I think there should be enough clearance. Looks fine, yeah. Yeah. Should be good. Okay, let's turn off the section analysis. Alright, cool. So the next thing I wanted to do was take a look at, let's turn off the, well, you can kind of see through the case, right? So you can see this gap between the PCB, the button PCB, and the screen. There's a little bit of gap, and that's fine. So what I want to do is push this as close to this edge as I can, and maybe leave like a 0.2 millimeter clearance there. So it's not exact, it's just for a little bit of freeway, but I do have enough room, and I do want to push them in. So to do that, I think the best way to do this is to go back in time in my timeline here, and go to this this feature here, which is called a snapshot. And a snapshot basically saves the state of the position of all the solids. In this case, their components. So, and it's in where is it? It's somewhere up here. Is it in symbol? Inspect. I'm looking for the snapshot button. It's somewhere. But anyway, I'm going to go back in time and see, and hopefully be able to move the positions, add a new snapshot, and then go forward in time, and then hopefully all those edits that I've done to cut all the things, all the holes and stuff, will carry out through. So to do that, everything is a component. So let's start with the D-pad. D-pad's over here. I'll hit the move button, and I'll just move it over ever so slightly. Let's go over here and start inputting some stuff. So let's try 1.5. Okay, 1.5 I think is going to do it. I want that little bit of clearance. I don't want it right up above there.
Show your CAD. You're not showing CAD.
Oh, not showing my CAD. Thank you. Oh no. Well, thanks for that, Pedro. So what I've been doing is I tweaked that thing, the case, and now I'm just moving the PCB here over. So that's it. See if I can recap. All I did was to adjust that screen was just move this guy here. I just moved the corner, moved it up a little bit, and then this one down a little bit, and then I showed you guys, well, I tried to show you anyway, the clearance issues that I had. Okay, so let's keep moving. Now I'm going to do the same thing over here. So I'll grab the button pad, or the button pad, click on move, and then I think I'll move it 1.5 mil over millimeters. Yeah, it looks about the same. So I'll hit OK. There's our position stuff. So now I'm going to hit capture position again. So now that's saved over here. So now if I push all of this back, I should be able to see everything that's happened, see all the edits that's happened to it. So let's bring these over, and they didn't, unfortunately. So there's a little bit of editing to do here since I moved everything. When things don't work. I think what I can do is open up some of these guys, like the actual sketches, and then see if I can move those over. And if that doesn't work, I might have to redraw them and reproject them, which is a little pain in the butt, but we'll see what happens here. So I moved it by 1.5, so let's double click on it. And when I double click on it, you can see it moved it back over because it sort of saved that state. So this might be a little bit of a problem here. Let's see here. If I go back in time, I might have to move these guys back over here because these, I believe these cuts were done after. Let's see. Let's see if I can move these guys. Essentially what I'm doing is I'm moving. Oh, awesome. There you go. So all I did was I grabbed those two captured positions and then I pushed them back before I did any actual edits. So extruding, filleting, split, shelling, all that stuff. I had to move it over. So let's move it all back and see if everything retains. Cross my fingers. And yes, it did. Awesome. Great. So that helps me a lot. I don't have to redraw everything. And that's my edit there. So again, I did a small edit up here. I moved our sketch up so that I have enough clearance. So let me turn on that section analysis to show you the cross section of where I had my problem. This whole red area here was actually intersecting with the Pi, the PCB of the Pi, and that's why I can't close the case. So I just moved it out a little bit more, and then I was showing you the washer stuff, where I 3D printed a washer. So I needed some clearance over here as well. So that's why I have a little bit of space here. And I think that's about it for those edits. So let's turn off the analysis. And you can see the bottom here. There is a little bit of room for some other stuff, maybe a speaker if you wanna add that. Let's turn this off. So there really aren't that many things that are going to be mounted to the second piece. So if I turn all these off here, you can see the only things that are mounted to this piece is the Power Boost 500C, and then again that one is held in place with these standoffs here and these little pegs. So that's how that's working. The battery is going to be, I think, press fitted into place because it's already pretty tight in there. So when you close it up, I think it'll just be held in place nicely. Let's turn that on, and then turn on the section analysis so you can see the battery. There's a little bit of extra room here just for in case there's wiring and stuff. And I guess if we wanted to like hold it in place, we could put a piece of foam tape or like mounting tack or something to hold it in place. Now I don't have a holder for the battery, mainly because you're free to use a different battery. If you want to use a 1200 LiPo, maybe it's thinner, or a different style of battery, you could add your own mounting thing if you wanted to, but I think that's fine. So the next thing I'm going to do is I guess I'm going to export this out as an STL. Well, first I'm going to save it. Let me go ahead and save it. And I like to add a little description, so I adjusted position of the buttons, gamepad buttons, and I also adjusted case size. I think that'll be it. Okay. Bring up my little data panel. These are all the components that that I modeled outside of the main assembly, and I definitely recommend doing that. If you have more than one or two parts, you definitely want to model all your stuff separately and then bring them in as a linked component, which is easy to do. If you want to do that, you just right click, insert into current drawing, and that will insert the it'll insert the design as a linked file, as a linked component. Okay, let's go ahead and extrude this out, or export this out. I do have to export both of them, so refinement medium, that's fine. I'll call it case top, replace the other one, and then case bottom. Replace. Alright, so what I'll do now is jump into Simplify. I'm going to print this on my Flash Forge Creative Pro. Unfortunately, I can't print it on the PrinterBot Play. It is 100 by 100 by 130. And the case is a little bit bigger than 100. You could cut it up into pieces, but for this one, I'm going to print it in one piece. So I'm in Simplify, and I need to rotate it. So what I'll do is I'll hit Command L so I can select a triangle. And when I select on it, it'll just flip it and put that on the bed, just like that. And another thing I found is to rotate it on the Z here so that it's long ways this way. I found this way to be better because there's less leveling problems, I found. So I like to print it this way. There really is less leveling problems because it seems like the further you go this way, the more you have to accommodate your leveling. So, okay. And another thing I wanted to share is what I like to do is instead of having extrusion width at auto, I like to set it at 4.2. Let me show you why. So if I put it on auto, it sets it to 0.48 millimeters. And when I visualize the G code, take a look at the wall here. You can see the wall has this zigzag pattern, and it carries that zigzag pattern all the way through. In my opinion, that's not the best. That's not the most optimal tool path. Let's say, why don't you just go straight across? Why don't you just give me 3 parameters going straight across the thing instead of zigzagging and creating these resonance problems like this this sort of thing that could happen when it's printing, because the machine's shaking a bunch. Sounds like a jackhammer. So what I'll do is I'll switch it to 0.42 and enter, and now take a look at the toolpath. Now you can see it's about 3 nice and clean toolpath, right? That's ideally what I like, is a nice toolpath. And the same thing happened with the standoffs. It used to be like zigzagging all over the place. Now it's nice and clean, in my opinion. So I think that's all I'm going to do. We can take a look real quick at the temperatures and stuff. I'm printing on PHA, which needs to be a little bit hotter. So, and I'm not printing with a heated bed, although I could. I don't need to on this one, because PHA prints pretty cold. I'm at 220 on the left extruder, because the left extruder has the active cooling fan. And I think that's it. Oh, for printing speeds, 90, 120. Pretty fast, but works pretty well on the FlashForge Creator Pro. So let's go ahead and export it out. Real quick look at my data structure, I guess we call it. My project structure. I have 3 folders. Source, which has like all the PCB stuff or any reference images. STLs is just STLs. And then builds is actual builds. So you can see here, name, and then the printer. Flash FF is for FlashForge, Play is for Printer.Play. And since I'm always using the same material, I opt out of using like PLA, like saying like -PLA, for example. Since I tend to only use PLA, I know it's PLA. So this is indeed the top. And I'll just replace that. And then I'll do the next one. The bottom. Bottom should already be set, right? Yeah, I just need to rotate it a little bit. Okay. Print. There you go. Cool. Looks fine. We'll replace this one. Okay. Alright, so I'll get my SD card. I don't have Octoprint set up yet on the FlashForge Creator Pro. I've been moving stuff around, so all the other printers seem to have it, but not the FlashForge. Okay, so what I'll do now is go into tunnel mode. Now I'll go over here and just answer some questions if there are any. Let's start from the top. Wow, there's a bunch. Oh, 3 p.m. here, not morning at all. Yeah, it's morning somewhere. Hello from Holland. Hello from Canada. Hello from the UK. Yeah, the printer is printing in the background. I am printing more drone parts for the Droney Trophy. It's I have to make 3 of them, and they're all like 10 parts each. Old Sega Genesis console. Oh, that would be cool. It is Game Gear-ish, yes. Happy birthday, Yanni. Yep, sorry about the CAD thing. Pedro had to come in. Yeah, Pedro's safe today. Thank you, Pedro. Hello from Greece. Wow, everybody's watching from Kenya. Oh my goodness. Good day, everybody. You can get the Adafruit screen from adafruit.com. I forget the product number, but just type in PiTFT. And can we see the buttons on the D-pad? Which buttons? The actual 6. These are 6mm buttons. I actually have an order coming in today from Mauser. Somebody gave me a part number. They're bigger than these 6mm, but I looked around and I bought some other ones that might potentially be quieter. So, but these are just the normal 6mm tack switches that are a little bit loud. So that's the button, and this is what I was showing you guys earlier. Any solutions for the lack of audio? There are some things you could do. We have a USB audio interface. That's the easiest way to get audio out of the PiGRRL Zero The harder way would be to use PWM and a couple extra components, but that's going to make, I think, the case a little bit bigger. I still have yet to play around with that, so I need to get myself that audio interface and figure out if I can fit that speaker in there, because although it looks like there's space, all that space is going to get occupied with wires. So that's one thing that's always, you gotta have a little bit of extra room for wires. The 3D printed button caps, I haven't printed those out yet, but here is the PiGRRL 2 with the 3D printed buttons. Let me see if you can see that. Yeah. And here's, I guess, the scale of it. It's kind of big. Thickness of it, it's just a teeny bit smaller. I didn't close that part yet. Show it that way. So it's a little bit thinner. But yeah, because of the form factor, it is a little bit on the chunky side and a little bit smaller. So that's the PiGRRL for reference. And then here's an iPhone. It's a teeny bit smaller than an iPhone 6 Plus. So that's just a bit of the size. Okay. Any other questions? Yeah, these buttons are going to have a custom PCB, and I guess I'll show them in here real quick. Let me open up one of them. And like I was saying before, it's actually going to be one PCB for both the D-pad. Let me switch. Let me remember to switch. For both the D-pad and the action buttons, I guess we can call them. So here's the PCB. It's just like I forget the size. It's like 30 by 28 something. I have a sketch here to tell me. Not that sketch. This sketch here. And what I'll do is I'll do another live stream later in the week to show you guys how I put together that. So it's actually 45 by 28.6. So I think it's about the same size as the PCB for this guy here, the Pi TFT, and just two mounting holes. That's it. So it's gonna be pretty simple. Again, just reuse the same PCB for the D-pad and the action buttons. They'll have all the traces for ground, so you don't have to worry about wiring all the grounds if you would, like you would with these guys. What I probably will do is wire this up with ground wires and stuff, because I think it'll get things faster. Obviously, I want to have this thing ready to play, make sure it feels good in the hand and works well. And then the way it's going to get wired is it's in through, let me show you guys over here. If you look at the PCB, there's actual little breakout pins here, the little holes there. So let me get this out. So either we'll eventually, I'll still have to figure out, do I need to wire them from the back or the front? Probably the front to keep things, come on, focus, to keep things nice and tidy. There you go. So you can see all the available pins there. Oh man, come on, focus. There you go. So there should be enough pins up there, and if not, we can either wire to the back here, which is a little hacky, like wire stuff to the back here, or because these pins are pretty tall, I could end up wiring to the pins themselves up there, like that, like wiring to these guys. So I mean, it's not as simple as the PiGRRL 2, because there isn't a breakout for Pi cable, but I think it'll be worth it to wire it in that way. There are some available pins up there, so hopefully that all works out well. Cool. Oh my god, I need to do shoulder buttons. So the shoulder buttons are going to come in. Let's do one tomorrow. Let's do a live stream tomorrow. I'll go ahead and do the shoulder buttons, because I need to have shoulder buttons. But this is still a prototype. It's in the prototype phase. I got to get the feel for the hands and the position of the components all goods. So I think it's going to be it for this one, folks. Thank you guys for tuning in. Later today is the show and tell at 7:30 Eastern Time. We have a show and tell. We have a bunch of folks come on, chat with Lamar and Phil, show off your projects, makerspaces, things that you're working on, woodworking projects, artistic stuff. All stuff is welcome. And then shortly after at 8 p.m. Eastern Time is Ask an Engineer with Lamar and Phil, Raspberry Pi, open source, Arduino, new products, secret stuff. And there's a coupon code, so if you want to pick up any of these parts in the Adafruit shop, you can get 10% off. I don't know what the coupon code is. It's a good one. It'll be announced at 8 o'clock, so tune in for that one. Remember, Eastern Time. All right, folks. Well, I really appreciate you guys coming in. It's morning for me, and sort of morning. It's 11:30 a.m. here. But anyway, I will see you guys tomorrow, I think. So yeah, thanks guys again. Be sure to subscribe, hit those like buttons and all that good stuff, and I'll see you guys later. Bye guys.